Okay, today we are going to discuss the seasonality data. So I gave you the air passengers data set in the homework number 16. So today we are going to discuss the data and discuss about the seasonality. And first of all, I want to plot the data set. So let me plot. I just show you the data first. So air um, passengers. Oops. Yes. So it is the number of the passengers from is 1949 to 1960, and it is the monthly data set. It's from the January to the December. So let me plot the data. And it is um, the time series plot for the data. The very last one is the December in 1960. So it is a December and November. I think in the middle, I think it is a little bit shift. So in the middle, there is the October, it's a September and August. And it's maybe this one is the July, June. It's a February and January, and here is a December, and it is a November again. Okay, so I think it's at the bottom. This one is a November and November. I think that might be the November. Can you remember when was this one? It's a November, December, November, October, September, and August. I think the peak is the August, summer vacation, and November, we have Thanksgiving, but was it the international airline passengers? Yeah, please, briefly, I gave you the description of the data set. It was the total of international airline passengers. So even though we have a Thanksgiving break in November, but it is the international one. So there is a peak in August and there is the least in November, right? So there's a pattern. It's every August. We have the peak. Is every summer. It's not just only the August, but it's a July, August. There is a peak and drop down, and the least one in the November. But when I look at the trend, it's a trend by year. It's increasing. And please look at the variation. The variation is also increasing, is later. So first, we need the log transformation because of the non-constant variance. So let me take the log transformation. Yeah, it is much better. It's a constantly, as a linearly increasing the number of passengers, and I can see the constant variance. Okay, so now, yeah, we take care of the variance by the log transformation, but still it is linearly is increasing. So because of the problem is increasing, as absolutely the increasing is not the stationary. The first of all, the definition of the stationary, yeah, we need the constant mean. But now it is the average is increasing by the time. So now it's not only the log transformation, but also let me take the difference. Simply just to take the difference, it is a solution to take care of the increasing means, right? Then now It's a mini co-zero because simply we just take the difference. It's neighbors, January and February, February and March. So now it's a little bit is a constant variance and it's not increasing, but still, let's look at this one. The very last one is the difference between the November and December, and the next one is the October and November, right? So it's a let me go backward. It's a down, up, and here's the is almost the same pattern here, right? It's a down, up, and down, up, right? So still, even from the difference of the time series, we can see the pattern. So this one and this one and this one is look same, right? So it has the pattern. So now let me take the A shift and PA shift using the function of the ACF number 2. So it is the A shift and PA shift is after we took the transformations. But you know, here's a leg 1, and I think it's after this one, if after end of the plot is the leg number 2. Because the reason why it is leg number 1, because let me count is how many is between is a 0 and 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. What is the number of 12? It is the number of months, right? So it's because of that, even though it is the h equal 1, it's h equal 2, but the number of legs is only 1 here and 2 there. So, you know, now we have a seasonality by month or by year, right? So we need is more legs. So when you use the function of the ACF2, is at the end, we just add is one more option. It's a max dot leg. It is the maximum number of leg. I suggest to use 48 because at least I want to see the A shift, PA shift for 4 years, 48 months. So now here's the first year, the 12 month, and another 12 month here, and the third year and fourth year for 4 years. So when you see the at 1, at 2, 3, and 4, you know, actually that is the difference. That is the difference between is a January and December. Is more details I have to say. It is the difference between the difference of January, February, and the next difference of the January and February. Do you understand what I'm saying? Right? Because it's already we took the difference once. It's between the neighbor month, right? And this one is the difference between the last year and this year. It's between the differences. So this one is the difference of the differences, right? So please try to understand what is the A shift at 1, right? So actually it is the difference between last year and this year of the differences, right? Yeah. So it's actually it is the we have 2 kinds of the differences here. But anyway, between the last year, this year, and this one is the 2 years ago and this year, and this one is 3 years ago and this year. So it makes sense, right? So because we have a seasonality, it's by year, right? So definitely it's every year at the same month, in the same month, we had the maximum and the minimum, right? So because of that, as we have a seasonality here, so later we are going to fit the ARIMA model as using the function of the S-ARIMA. We have 2 kinds of parameters is later. So the first one is the small one in a year, and the next part is another parameters for the seasonality. So now I can suggest you. Last night I read the textbook, but even it was not clear. Even I couldn't understand what was that. But now today I will try is a little bit different way. So in this case, just roughly is look at the A shift, PA shift is by year. That means please roughly look at this one and this one, the second year, and the third year and the next year. Okay, it's only this one by the seasonality, roughly. So roughly I can say the A shift is a decreasing, the trade-off, and a PA shift is a cutoff at the first year. So what was the trend of this one? Can you remember that? Tails off in A shift and cutoff in PA shift. It was AR, the AR model, right? So we just plug the P was the number of parameters in AR part. So the P is equal to 1 and the Q is equal to 0. So by the seasonality, we can suspect it is the AR1. Okay, so now we take the P and Q for the seasonality, and now we have to look at the other one. I mean the other one means is inside of a year, right? So A shift is looks like it's a little bit is above here and down and up and down and up, and almost it's exactly same pattern. It's up, it's a down, up, down and up, down and up and down and up. Can you see that? The same patterns? But the PA shift is a PA shift has the it's a down and down, but yeah, it's a after one there is a nothing. So please focus on the first year in A shift here and the PA shift there. Yeah, so it is not clear. So let me try make another is another A shift and PA shift, taking the seasonality. So let me take the difference again. Let me take the difference again. And let me take the 12 here. It means, you know, we just take the difference. It's like this one, right? Then it just take the difference with the neighbors, the first one and the second one, and second one and the third one. But it's another difference is one more difference is outside of the here, and there's a 12. That means take the difference with the first one and the 13th one. I mean that we have to take the difference between the January and February, right? So we just take the number is here. How much is apart is between the two values. So this difference was for the how can I say, the delete the increasing trend, okay? And outside of the difference here, we have to delete the seasonality. So now we can delete the seasonality is by taking the difference between the January and February, right? So let me make the A shift and P shift again. Yep, it is the pattern. It is a pattern of the A shift and PA shift. Is when we delete the seasonality. So when I delete the seasonality and look at the A shift and PA shift, I think they are not tails of and tails of, right? Yeah, it is not clear because a little bit is higher than 0.05 here and lower than this 0.05 again there, right? And here is a lower, and there's the bigger, right? So it is not easy to define is another is a parameters. So simply let me try is a change the number of parameters in the ARIMA model. So now let me apply the function of the S ARIMA. And now let me plug only the log transformation on the data set is air passengers. So now, yeah, please make sure we just take only one transformation, the log transformation, because of the non-constant variance. So now here first, we have to plug the parameters, the number of parameters without the seasonality. And then we plug is another set of the number of parameters, it's a PDQ, for the seasonality, and finally we take the length of the season. That means the very first I suggest you just apply is a 1 and 1 and 1. When you are reading the textbook, this parameters is a small p, small d, and small q. So that is it must be from here. When we delete the seasonality. So it is not clear. So simply just plug the P equal 1 and the Q equal 1. And in the middle one is for the difference. I mean this difference. Yeah, we took the difference because of the increasing trend. So this one, it is a small d equal to 1. That is taking this difference, not this one, right? Because we didn't plug the DIFF here, right? So we plug the small d equal to 1. And it's not quite, it's a reasonable, yeah, it is not easy to explain to you why the small p and small q is equal to 1, but initially, yeah, it's from the HF and PHF. Yeah, I just, the textbook just plug the 1 and 1, right? And then now, yeah, we plug, there's another 3 parameters. It's a P, D, Q again for the seasonality. As I told you, we have 2 parts. The first one is the without the seasonality part, and the next one is the seasonality part. And the textbook has the notations. It's a big P, the big D, I mean the capital P and capital D and capital Q, right? So the before we took the AR1, let me show you the pictures again, is later. The very beginning is with the seasonality. You know, the A shift is as a trade-off, it's exponentially decreasing at the first year and the second year and the third year. Can you remember that? And the PA shift was the cutoff, is only the first year. So we chose the capital P is a 1. And definitely we take another difference. It's another difference for the seasonality. So the next one is the capital D is equal to 1 again. Yeah, because of this difference, this difference by the 12, right? And now the Q, the capital Q is equal to 0. Because we saw the trade-off in A shift and the cutoff in PA shift is before. Let me show you again. And the seasonality, that is a 12 month, right? So it is a little bit different. It's from the homework, from the model I gave you in the homeworks, because I gave you is a 1, 1, 1, and 0 is 1 and 1. But let me try, it's a little bit change for the seasonality. Capital PDQ is a 1, 1, 0. It's not 0, 1 and 1. But let me try this one. Actually, it is the purely the seasonal is ARIMA model. Yeah, it has two parts, this one and this one. You know, um, this one is the one, and yeah, I told you it has the seasonal ARIMA model has two parts. The first one is a smaller one, and the second one for the capital one for the seasonality. And in the bracket, that is the number of the period, right? So the standardized residuals is between is roughly, I think here is a 2 and there is a 3, right? So it's between plus and minus 3, and this one is the A shift of the residuals. It looks good, and it is almost a normal distribution. And even the p-value is some p-values at the beginning and here and later is not so good, but it's roughly it looks good, right? And here is the here's the a, you know, we suggested we tried is a small p dq and the capital P dq, right? So it's a small the small p1 here and the small q1 here, and this one is the S ARIMA 1. It means that the capital P is equal to 1. So here is the 3 parameters, and this one is the t table with the t values and p values. T values and p values. Now is the AR parameter is not significant. So that means we can try again. It's a delete. It's a this one. So we can delete. This one is equal to 0 because the p-value for the small AR1 is not significant. So we can delete the AR1. I mean the small p1. Let me try again this one again. You know, the diagnostics picture is almost the same. Yeah, at the beginning it's almost 0.05 and later it's the same thing. And it's all p-values is yeah, very significant. It's almost 0. Yep, it's now this one. So it's initially, yeah, it's almost no reason. Yeah, we plug the small p is equal to 1 and small q is equal to 1. But look at the p-value from the output. Yeah, even we can change. Yeah, we can change it a little bit. It's like this way. Anyway, in the homework, I gave you 111, 111, and the capital P is equal to 0, and capital Q is equal to 1, right? So let me try this one. Now, okay, just a second. Yeah, I'm sorry. Now the diagnostics picture is not so bad, but I concerned is about this one. This one at this time is a little bit higher, right? Yeah, but the p-values is later one. You know, before the later one is almost 0, but now it's a little bit better. And still the AR1 is not significant, but now the capital Q, the seasonal MA1 is a significant. So it is not bad. So let me try again. It's one more. It's a delete the small p because it was not significant. So let me try this one again. Yeah, still it is a little bit is higher than 0.05 and p-values is almost the same. And the MA, the small q and the big Q, yeah, is a significant. So there is not a big deal, right? So we tried is a many parameters. It's a little bit we change. It's a little bit, but the seasonality ARIMA model has two parts. This one is the seasonal part, and this one is the original one. Okay. So I can suggest to you, yes, it's at first you just plot it's only the simple transformations. With only the simple transformations, we can make the A shift and PA shift, and you can see the seasonalities. and also just plot the data, the raw data, then even you can see the seasonality, right? So in this case, you know, the final goal is to make the white noise. That means as not only in the time series model, but also is any kind of the statistical model, we have to delete is any effect. Yeah, that is the is analyzing the data. So in the analyzing the data, that we delete is as much as we can any effect, and take the remaining parts. The remaining parts is the residuals, and if the remaining parts, the residuals is small enough, I mean now in the time series the residual is the white noise, then we did our best. We did our best to delete the effect. So in this example, we take care of the constant variance because at the beginning, the white noise was assumed with the constant variance by the log transformation. And even the increasing, you know, the white noise is not increasing. So take the difference the first time. I mean, take the log transformation first. Yeah, so take care of the constant variance and take the difference, right? It's because of the increasing. And we took another difference because of the seasonality, right? So now look at this one. Now we can see the seasonality here because we delete the seasonality this one. So as much as we can, we take care of the data, that is the analyzing data. And finally, as we want to make the white noise, the IID normal distribution, right? So it is the analyzing the data in the time series. And the last topic, the seasonality of the ARIMA model. Okay, so and also the last one is the another is a good function forecasting, right? It's SARIMA dot 4, and don't forget it's a put is how many futures. Yeah, it's a you have to plug there's how many futures here for forecasting. It's a 24 means it's forecast. It's a 2 more years in the future. So in the with the model, with the seasonal ARIMA model, right? So it is a very good one, and it has it gives us it's very beautiful the forecasting pictures. So the black one is the original data is with the seasonality, and by the seasonal ARIMA model, we can do the forecast here. I think the I'm not sure the darker one is maybe the darker one is the 90% or 95%, or um, the outside one is the bigger one, or 95% or 99%. But I didn't look at the function carefully, but it suggests to us is two kinds of the confidence interval for the forecasting. So it is very useful. The functions in I think it is a function in the package. So anyway, today is the last lecture. Discuss about the seasonality ARIMA model. So if you didn't try the homework number 16 yet, yeah, please try copy and paste, and please look at the pictures and the data, and you can try it's on other models as well. And now today, not today, it's a someday. I think about the final exam. The final exam is it's almost the same as what we did in the homeworks, right? I will I will give you the data, and I will suggest to you plot. And for example, I will suggest to you. I can suggest to you plot the data. It's like this. Then I can ask you, what do we need? Then you can answer, we need the log transformation. It's because it does not have the constant variance, for example. And also, then I can suggest to you this, then take the log transformation, plot the log transform the data set, and then ask you as what do we need? Then you can answer is we need the take the difference because it is increasing. It's like that, right? So now I'm thinking about the final exam, but the final exam is like as the homework. It's homework number 16, 15, it's a 14, 13. So it's a trial game. It's a now I'm recording this lecture and I will post this one is as well today, it's later. So please watch the video clips and what we did and what I explained to you. And please try one by one again. And please think about how can we build the data. I'm sorry, to build the model, the ARIMA model. So, but still I'm thinking about the final exam. So do you have any question? Is anything the final exam or the seasonal ARIMA model? Okay. If not, you can leave and have a good day. And I will email you someday. As probably